Okay, guys, here we go. Unit 13, probability. So a little bit of talking in the beginning here, and then we'll get into doing a couple questions. All probability is quantifying chance, which is how likely is something to happen. And we see obviously right now in the news a whole bunch, them testing out medicines, right? Seeing if maybe something can be used to help cure some of these people. Industry, the life of a product, how long might a light bulb last, or any products you can see on there, they'll have a shelf life. Biology, the chances of you passing on some gene to your children. That's something that's used all the time when people have some kind of sickness and they're considering having children. They might sit down with a doctor and they'll let them know what the chances are that they could pass on a certain disease. All right, so here's our formula for probability. I know it's wordy, but we'll make it simple, but we'll read it first. So the probability of some event happening is the number of times the event can occur divided by the total number of outcomes. The bottom is always called my sample space. But very simply put, like if I was going to roll the die in the classroom, the bottom number would be 6, right? Because there's 6 possible outcomes. But like what if I wanted to roll a 3? How many 3s are there on the die? There's only 1, so it would be 1 out of 6. Okay, so sample space is our bottom. It's all possible outcomes. Theoretical probability is when an experiment doesn't actually take place. It's like in theory. What do we think might happen? Empirical probability, EE, an experiment does take place. And then there is a little formula here that I do want to just throw at you, the complement of event. So the chances of something happening plus the chances of something not happening, it always equals 100% or 1 whole. But we can think about the weather. If there's a 40% chance of rain, then isn't there a 60% chance of no rain? So it always adds up to 1 whole or 100%. All right, so let's take a look at our first one. It says, given the formula to calculate probability, between what 2 numbers must all probability lie? So we just went over that, 0 to 1, or 0% to 100%. 1 second, I gotta let the dog out. Come here, go. Okay. A die is rolled once, calculate the following probabilities. So again, every single one of these is going to have a denominator of 6. That's the sample space. What's all possible outcomes? And we're just going to start with something simple like a die so we can refresh our probability. So what are the chances of getting a 3? Well, there's only 1 3. What's the chances of getting an odd number? Well, on a die, right, we have 1, 2, 3, 4, 5, and 6. So how many of them are odd? 1, 3, and 5, so 3 out of 6. And you don't have to reduce. You can leave it as 3 over 6. What's the probability of getting a number less than 5? Well, isn't that 1, 2, 3, 4, 5? So 5 out of 6. Probability of getting a number greater than 2. So 3, 4, 5, 6. Probability of not 4. So that means all the other numbers except 4. So 5 out of 6. And probability of not odd. So not odd are all the evens. So 3 out of 6. Remember, you can rewind, pause. I'm just trying to go through the video so it's not too long. If the probability of an event happening is 1/7, what is the probability of it not happening? So just like we said before with the rain, when it was 40% chance of happening, how did you really get the 60% of it not happening? Wasn't it 100% minus the 40%? So in this case, we're not working with percentages, we're working with fractions, so we'll do 1 minus 1/7. So you can throw this in your calculator if you want to, and we're just left with 6/7. We can skip 4. Okay, 5. If A and B are complements, so remember, if they're complements, again, this is just adding up to 100% or 1 whole, then which of the following is true about probability of B based on the probability of A? So I think it's best to write the formula. So the probability of A plus the probability of B is equal to 1 whole. So we could go through every one of these. You're just manipulating, you're just moving around the pieces in the formula. So I'm just going to show you, it's this guy right here. They solved for probability of B. So if I solved for probability of B and I subtract the probability of A, I can see that would be the answer. So if you went through all the other ones, none of those would work. Okay, let's check out some more just basic, simple probability here. So it says a survey was done by a marketing company to determine which of the 3 sodas was preferred by people in a blind taste test. The results are shown below. Find the empirical probability, so that means an experiment was done, that a person selected at random from this group would prefer soda B. Express your answer as a fraction, and, so we want 2 answers, and as a decimal accurate to 2 decimal places. Okay, so our bottom is going to be our total, right? 53 were surveyed. And then how many preferred soda B? So 24. So 24 out of 53 is one of our answers. Throw that in the calculator. Let's convert to a decimal. 0.4528. Round to 2 decimal places. 0.45. All right, find the empirical probability that a person selected at random from this group would not prefer soda A. And express your answer as a fraction and as a decimal again. Okay, so not soda A. So not soda A is just everything else. So we could do 1 minus 24 over 53 if we wanted to. Or you guys could just add up the remaining ones. Oops, I circled the wrong one. Okay, so we get 35 over 53, so that would be one answer. And convert to decimal. To 2 decimal places. And there's my 2 answers. All right, this next part is going to lead us into some lessons that are coming the upcoming days. So it says the results of a survey of the student body in Central High School about television viewing preferences are shown below. If 1 student is chosen at random, find the probability a male whose preference is comedy was selected. So before we do any of these, I want us to look at all 3 and decide what the sample space is. So remember, our sample space with the die was the number 6 because I had 6 possible outcomes. So who am I choosing from in each one of these? So that's what I want to look at before we do any of the questions. So in the first one, it says if 1 student is chosen at random. So my bottom number is going to be 490. I'm choosing from everybody. In the next one, it says if 1 male is chosen. So now I'm only looking at the males. How many males are there? 230. And in the last one, it says if 1 student whose preference is reality is chosen. So reality is my bottom number. All right, so now let's go back and do every one. So if one student is chosen at random, find the probability a male is chosen. So males and comedy, 95. If one male is chosen at random, find the probability his preference is comedy. So now we're going to find how many like comedy. 95 out of 230 this time, though. and one student whose preference is reality is chosen, find the probability it's a girl. So I'm only looking at reality again, and how many are females, 110. Okay, so in this particular example, I wanted the sample space to stand out to you. Who am I choosing from? Okay, next one is the same type of question, except you can see they didn't give us the totals. So this is common that you have to put in the totals. So I'll add up going this way. I'll add up going this way. I'll add up going down, and just gotta squeeze this in here. I'll add up going down, and I'll add up going down. And then one more, and then this guy is gonna be our total. Oh shoot, I erased the wrong ones. Sorry for all the background noise. My dog has to eat right now. Oh, there she is. All right, so here we go. So we're going to do the same thing like we did before. We just had to put the totals in. So if one student is chosen at random, find the probability they are a girl whose favorite sport is basketball. Okay, so one student is chosen at random, so that means my bottom number is 220. Right, I'm choosing from everybody. And now we're doing female basketball. So 30 out of 220. Now it says express your answer to the nearest 1/10 of a percent. So let's turn this into a decimal first. And then move 2 places to the right. 13.63%. And then let's round. So 13.6%. Let's try again using the same chart. If one male is chosen at random, so now I'm only looking at the males. So how many males are there? A total of 98. And we're going to find the probability that lacrosse is his favorite sport. So we're just looking in the males column, and lacrosse, so 37 out of 98. Okay, a few more things here from the past. Hopefully you did this in middle school. It's called a tree diagram. So a fair coin is flipped 3 times, and the result is noted each time. The sample space consists of ordered triples, such as heads, tails, which would represent heads on the first toss, heads on the second, and tails on the third. So we're going to draw a tree diagram to show all the outcomes. All right, so it looks like this. So the first time you flip the coin, you could get heads or tails. Now we'll pretend that we got heads, and now the second time you could get heads or tails. We'll pretend we did tails the first time. You could get heads or tails. And now we'll go along each branch. So if I got heads and then heads, I could get heads, tails for the third one. Heads, tails. Heads, tails. Heads, tails. Now if I want to write out my sample space, I'm going to read along each one. So let me grab the highlighter and just show you. So like when I want to see what the first one is, I'll just read along like that. So heads, oopsie. So heads, heads, heads. And then if I want to read along the next one, I'll use a different. So now it would be heads, heads, tails. So you see what I'm doing? You just read along each one. But I'm not going to highlight every one. That's going to get a little crazy. So heads, heads, tails. Or we could have went heads, tails, heads, heads, tails, tails. So I'm done with that side. Now we'll go along the tails one. So tails, heads, heads would be my first one. tails, heads, heads, and then keep going along. So tails, heads, tails, 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 heads, and the last one is tails, tails, tails. Okay, so it's tree diagram. I just wanted to show you how you could list out what all the sample space is if you're doing something 3 times, more than once. So list all of the ordered pairs. So we did that. We did that right here. How many of them are there? Add them up, and you get 8 of them. Okay, now they're going to ask me a question. So find the probability of each of the following. So getting all tails. All right, so first, the bottom number is 8, right? That's my sample space for both of these. And then how many times do we have all tails? I think that only happened once. And then how many times are there exactly 2 tails? So exactly 2 tails. Let's see. So we have 1 and we have 2. So 2 out of 8. And then before we leave this page, I just want to show you something else, how we could have got this number 8, and it's going to lead into the following page. When you flip the coin the first time, how many ways could it land? It could land 2 ways, right? When you flip the coin the second time, how many ways could it land? 2 ways. And when you flip it the third time, it could go 2 ways. This is called the counting principle. The amount of ways each thing can, the amount of outcomes for each scenario, if you multiply them, you can wind up with your value. It's called the counting principle. Okay, so let's check that out on this next one. So the counting principle states, if you can do one thing in m ways and another one in n ways, you can do them together in m times n ways. So if a wedding menu has 3 entrees, 2 soups, and 4 desserts, how many different meals can be made up? Well, all we have to do is multiply all our values, and we're left with 24 different ways. Okay, a few more things here. So what's going to happen in number 11 is we're going to have multiple events, but just like we did in number 9 and 10, but we're going to calculate the probabilities now. I don't want to know just how many ways it can be. All right, so let's check this out. It says a jar contains, and I always like to come over to the side, 3 blue, 4 red. You should take out all your data on the side, and 5 green marbles. Now, it says a marble is selected, the color is noted, and then it's replaced. So look, before we do any of the questions, I need you to see this. Then replaced, not replaced. That's going to make a difference in the sample space, because if it's replaced, my sample space will be the same, so the bottom number will be the same. But if it's not replaced, then my sample space, the bottom number, will change. It'll decrease. Okay, so this part here is important. Multiple events, we multiply the probabilities. All right, so what's the chances of getting blue? Well, how many marbles are there altogether? Altogether we have 12. How many of them are blue? Times, now I replaced it, so that means that that sample space is exactly the same. How many marbles do I have? 12. How many are green? 5. You can throw this in your calculator, or you can just multiply straight across. So 15 out of 144. Okay, it's multiplying with multiple events. Okay, next. So now this is a new scenario. Okay, so new scenario with the same bag of marbles. A marble is selected and then not replaced. So what's the chances that the first one is green? Well, we have 12. 5 of them are green. Now it says not replaced. So my sample space went down to 11 now. What's the chances of getting red? And now we're just going to, again, multiply straight across. So we get 20 out of 132. Okay, and then we'll do one more. But again, you're pretending like, we're starting over with the marbles. But it says a marble is selected and not replaced. So what's the chance of getting green? 5 out of 12. But now, what's the chances of getting green again? Well, you have to assume that you got green that first time, and we know that the sample space went down by 1. So 20 out of 132. Okay, so that's just probability of multiple events. This first day is just supposed to be a review of like probability that you did in middle school. We're not going to do number 12 because cards are not on the Regents, and I feel like you guys don't always remember cards. Okay, this question though was a Regents question, so let's see if you guys can do this one. So if you want to pause and try this one, that would be great. Okay, so we have 11 calculators. 3 of them are defective and 8 of them are good. Always take your info out on the side. If 2 calculators are selected, and here it is, guys, with replacement, so that means the denominator is going to stay the same. And this is multiple events, so I'm going to multiply my probabilities. The denominators will stay the same. That's your sample space. All right, how many are defective? Right, I want to know the probability that I'm getting defective, like if you wrote out your own little thing. So 3 out of 11, and then I put it back in. So 3 out of 11 again. Multiply straight across, and we get 9 out of 121. Okay, and then the last thing here is just, just review topics that I want to put on the test as we get closer to the end of the year here. All right, so we're going to find the roots in simplest A plus BI form. Okay, so this right here gives it away to me that this is going to be quadratic formula. It also tells me, I have to set this equal to 0. There's going to be a negative under the radical, right? So I can tell already here I'm totally not going to have enough room. So I'm probably going to go into the space below and then erase it. All right, so I got to add 2 to both sides. So we have 3x squared minus 2x plus 2 equals 0. My A value is 3, right? This is all review that we know. B is negative 2, and C is 2. Remember quadratic formula? It's on your reference sheet. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. Okay, X equals negative B plus or minus the square root of B squared minus 4A C all over 2A. Okay, so we get X equals 2 plus or minus rad negative 20 all over 6. From here, remember we break it down? So it'll be the square root of negative 1, and then the largest perfect square that goes into 20, so 4 and 5. And now from here, I'm going to come down here and use this space. Okay, so we get X equals 2 plus or minus 2I rad 5 over 6. And now we reduce. Let me move this up. Oh, I can, yeah, okay. All right, so now we reduce. GCF is 2, so 1 plus or minus I rad 5 over 3. But now it did ask for us to be in simplest A plus BI form. So remember, you have to decompose the fraction and take it apart. So 1/3 plus or minus. You can write it as rad 5 over 3 with the I right next to it. That would be your A plus BI form. One second. Okay, and then I think we just have 2 left. Okay, so these guys right here. So I'm just going to erase this now because I need the space back. Okay, so again, this is just old topics. I'll write the equation of a circle. whose radius is 9, and center is 0, comma, -4. Okay, so remember the equation of a circle is x squared plus y squared equals r squared. And if it's not, this is at the center, right? Center 0, 0. If it's not, we have to do the horizontal shift. So this would be x squared plus, and right, remember it's the opposite, y plus 4 squared. And now I gave you 81 on purpose because it's not going to equal 9. It equals the radius squared. So we have to do 81 squared, which is 6,561. Okay, I did that on purpose so you really think about it. All right, and then the next one, what if I give you the equation? So the center, remember it's the opposites, and then the radius is the square root of the last one. Okay, so just some nice old topics that I'll put on the next test. Okay, so I know the next page says day 1 homework, but I'm not going to assign that. I'm going to assign Delta Math. All right, guys, good job. Rewatch the video if you need to. Bye.